When you open a 3D software, especially the kind used for animation, you'll see that everything is made of these wire-like structures with loops spanning the entire structure. This is the topology of 3D mesh. Now, topology refers to arrangement and flow of these vertices, edges, and faces that make up a 3D mesh. It dictates the structure of your model and plays a pivotal role in determining how well it deforms, animates, and subdivides. Now, once you get a bit nerdy and gain some hands-on experience, you'll start recognizing topology in everything around you, not just in 3D softwares. Similar to real-world structures, these vertices and polygons define the topology of an object in 3D. The more polygons you have, the smoother the model and allowing for more intricate details, but impacting the performance. It's going to be more laggier, going to perform slower. So reduce these vertices and polygons and you'll start seeing jagged meshes, but the model can perform in real time using less resources of computer, even handling large number of these objects, a crowd of people, let's say, while maintaining a good computer performance is quite possible and easy for gaming engines. The next time you play a game with crowds like FIFA or WWE, and notice, as you see in this footage, John Cena and Randy Orton have all the muscles and everything, while all the people in the crowd doesn't even have fingers. So understand the developer were not lazy, so they were just managing polygon counts to ensure that the game performs well and investing more resources in characters like John Cena and Randy, whom players pay for basically, and not these people. So in summary, denser topology results in high resolution model, and when things get high resolution, needs more resources. The good thing is that you're living in fortunate times where you don't have to model and create entire character in just 50 polygons. So 15 to 20 years ago, this is how the characters used to look like in 3D games. Her entire body is less than 1/10 of resolution of this sandwich from current gen game Starfield. Now understand, even though this game might look visually outdated to current generation kids, it used to be a big deal for us. It inspired the whole action RPG genre and continues to influence many things to date. So although times are more forgiving now with powerful hardware, it's still crucial to respect and manage mesh resolution despite technological advancements. So nowadays games are incredibly detailed and expectations are even higher, and even there are new things like AR and VR. So managing 3D meshes is still a thing. So forgive me for assuming everyone here is new to 3D, and I might state some obvious things, but it's necessary to get few points across. Now I'll start with few absolute basic examples because there's a whole wide range of audience on my channel. So I need to be a bit more considerate. You never know where this video is going to land. So let's assume this is a leg. Just bear with me. Now there's an armature underneath it, which is driving its motion. So if I try to move it, it's not going to move this object much because it's like a Lego piece at this moment. Literally there's nothing in it. But now if you go to edit mode and add one more loop here, then you'll see at least this is like bare minimum required for making a leg's motion. But now if you want this to have some more smoothness, you can add few more loops here so that there are more loops to support this deformation of the knee. And then you keep on adding basically. From here on, I can do anything I want. So now it's like officially a leg. And then if I pay some more attention, leg only bends in one particular angle. So if you come to think about it, we need more loops here and less loops here. So if I was working in polygon constraints or something, then I can just bevel this here and I have more loops to bend. But now the problem is here we have 5 points. So this makes it n-gon. So it's quite easy to fix. Just take this one and connect it here. You have quads everywhere now. So this is just for an example. Don't go on and adding an armature and then start modeling. All right. And then there is no end to it. You can just keep on adding loops if you want and keep detailing your model. The more loops there are, the more it's going to deform well and can carry more details. So let's say if you have some muscles here, or if you want to put some corrective shapes, then for that you need some more loops here. So these things would help with it. Let's shade smooth this. And then let's say if you wanted to have some more muscular details here, you can just tweak few of these loops and shape it more like a leg. So I'm just going to try and eliminate every triangle or n-gon I see. Now that I have proper quads everywhere, if I want to add some more details to this object, I can just press Ctrl R and keep on adding more details. And this is going to be quite easy because the entire mesh is following a neat structure. So let's say if I move this here, I can maybe make it look like a muscular leg or something. So now I have more points to work with. So I'm just going to try and utilize all of these. And then you can say we have a detailed leg here. So it's not that I'm trying to achieve a perfection in model here. It's just that the point is, the more loops you add, it helps you define the mesh better. It makes it convenient to work with the mesh. You have loops, adding details is much more easier, and then it deforms well. So on every level, clean topology helps you in many ways. Now let's say if you had, instead of subdivision surface, if you put some multi-resolution here and subdivide this a few times, let's say 3 times, then I can just go to sculpt mode, maybe paint out some of more details here. And now here we have plenty of resolution, and I can keep on adding more details to it. I can go to depth of any details if I want. This resolution is quite high, and I can subdivide this further if I want. But the thing is, we are losing the performance on this model. You can clearly see as I scrub the timeline, mesh is higher, it can support details, but it's no longer an optimized model. So imagine if we had an entire character in this resolution, that would be a disaster to animate and render. And this is where normal maps come in. So if I just quickly grab these vertices, mark seam and unwrap this, then I can just create a new image texture 4068 by 4068. Make this one non-color and put it into normal, and then just work in the low resolution here, disable all these subdivisions, and then I can simply bake all the details from the sculpt that we did into this texture. So if I click on normal map, bake from multi-resolution, and click bake, and this is going to take a few seconds, and then now I can bring a normal map here and put it into color. And if I try to render this now, you'll see we have all the details from the high resolution model, but in a normal map, which is right here. So this is a normal map image which we have generated from high resolution model. So now this model is low resolution, but it's also carrying all the details from high resolution model, which is using 6 subdivisions. And now we have a good feedback while we animating this. So frame rate is high, it's easy to work with, easy to modify. We can have an entire character in this resolution and it's going to perform quite well. So even if I get rid of this multi-resolution modifier now, you'll see we still have all those details in normal map. Hope this gives you an idea about handling resolution and everything. As you become more familiar with topology, you'll discover it's not meant to complicate your life. It's there to simplify it. According to me, differentiating between good and bad topology boils down to 2 major factors: performance and appearance. So the arrangement of these vertices and edges should follow the natural contours of object. That ensures the models maintain realistic and good appearance. Good topology allows addition of intricate details without distorting the overall shape. With a fewer well-placed loops and mesh flows, you can easily accentuate the forms in the object or body. A consistent density of mesh across different parts of the model ensures a uniform level of details, controlling a visually pleasing appearance. So just because if one part of the body is bigger than the other or one is smaller, it doesn't mean it requires less mesh or more mesh. To capture the right details, you need to put enough loops, otherwise things would fall apart in the close-up shots or something. The topology should also facilitate smooth surface, enhancing the visual appearance of model. Quad-based topology subdivides well and creates smoother surfaces. Well-organized topology streamlines UV mapping for improved texture application and detailing. It's very easy to work with a clean mesh where the topology is well organized. Selecting loops, cutting down the mesh, modifying the geometry, laying it flat for UV is much easier task, and often if topology is cleaner, there's a less chance for distortion and visible stretching in textures. The topology should be well optimized for performance. Whether you are making it for a game or movie, it still needs to be under a certain quota. So it's important to manage a right balance between how well your model looks and how well it performs in rendering and animation in the later stage. Minimizing polygons with more than 4 sides, n-gons, helps in preventing issues with smoothing and deformation. So keep your topology based on quads as much as possible. A properly placed edge loops and strategic polygon distribution are crucial for animation, specifically for characters. Good topology supports natural movement and deformation during animation process. And we are going to talk about this in the very next chapter, where we are going to modify the loops of the face, which kind of resembles the actual human facial structure and muscles. Topology that aligns with the intended rigging system contributes to better deformation during the character animation. For instance, it matters what kind of rig you're planning to use to decide a topology for your character, whether or not it's going to be a simple rig or it could be based on muscle system. So keeping all those things in mind, you will have to make certain decisions about the topology of character. Additionally, editing a mesh is much more straightforward with well-connected loops in good topology. Tasks such as creating blend shapes and distributing weight paints for skinning becomes much more manageable when the mesh is clean. Now, every object has its own topology tailored for specific purpose. Likewise, in the 3D world, topology isn't one size fits for all idea. It varies based on different needs and industries. In the gaming industry, emphasis is more on performance. Models in game often utilize techniques like normal maps and stimulate intricate details, allowing game engines to handle extensive scenes in real time. Additionally, level of details (LODs) are used by game engines to preserve the high resolution details for objects that appear closer to camera while loading low resolution models or decimating a geometry for distant objects. This prevents loading lags and enhances overall gaming frame rates and experience. In the film and VFX sector, the focus is on achieving highly detailed meshes. Models sometimes are sculpted in millions of polygons to capture the intricate details. While these models may undergo retopologizing for creating a low resolution mesh for animation, higher resolution versions are used for rendering, incorporating displacement maps for realistic details. Now, CAD modeling, commonly used in industrial design, relies on NURBS curves. NURBS, defined by control points and weights, create precise and smooth surfaces. These models are particularly suited for product design and manufacturing. NURBS surfaces are often created by patching together multiple curves. This makes them well suited for creating automotive surfaces, product design, etc. But they often provide a tool to convert or export models to format suitable for 3D printing and rendering softwares. Now, within these diverse examples from the animation, film, and game industries, there's a wide variety of styles and complexities. From the cartoon industry to the ad film industry, indie game developers, motion graphic designers, indie filmmakers, experimental filmmakers, there's a whole mix of realistic, non-realistic, stylized, and abstract content. Here, rules are often bent to achieve the goals of designers, providing a sweet spot for experimentation and creative mixing. And this is where I have landed, and I have been working, exploring a variety of creative possibilities. Now, all this might be building up too much in your head, and all these words might be making it seem scarier than it actually is. Let me give you a few quick examples of how you can control and manipulate topology in a mesh. I'll give you a few basic examples, and later on you can chase it to your heart's content in your own time using these links in description, or you can do your own research. So this is a simple mesh object, a simple grid, just like any other primitives you have here. So when you're modeling, basically you extrude these points, edges, and faces, and this is how you model. So this low resolution model is quite easy to manage, to animate, render, and going to perform quite well. If I need to render this, I can apply a subdivision surface on this by pressing Ctrl 2. And this gives you a smoother surface, shade smooth. So this mesh, the main mesh underneath it, these points are there to control. This is what you control to model. But the smoother surface is what you use to render. Now, when you're working for a game, you don't get to use subdivision surface or anything. You just need to make sure your model on the base level itself have enough topology, and whatever is in the model is going to render in the engine as well. But when you're working in other animation industries, let's say film, TV or something, you can use subdivision modeling, and this generates all the in-between points, gives you this smoother surface. Now, subdivision surface takes the average of 2 points and creates this nice arc in between, which gives you a smoother surface. Now, in this case, if you need a sharp edge, you will have to add some more support loops. The closer these loops are, the harder edge it's going to create, like this. So that's how you model with the subdivision. Now, if I check the wireframe of this object, you'll see in between all these quads, we have multiple of subdivisions going on in between every face. So let's say if this is a simple grid and I apply one subdivision surface on this, it's going to smooth out all the edges and give me this circular kind of object. And if I need to have a sharper ends, I can add more edge loops. The closer these loops are, the harder edge it's going to produce. Working with subdivision would seem a bit tricky, but keep in mind it also gives you an advantage. So you won't have to create hundreds of points to make a simple smooth shape. For instance, create one simple inset with it. Let's add a few more loops here. Now I can get rid of these 4 faces. And now if I scale these down, you'll see we have a perfect circle here. Now without the subdivision, we still have these jagged hexagon kind of thing going on here. But with subdivision, you have this perfect circle, and this way you can easily achieve smooth and complex mesh transitions with the control of quite a few points. Now, when you're working with mesh, we have discussed plenty about this in the introduction series. You can subdivide it and this will give you more control over the shape. You can press Ctrl R, add more loops in a particular order if you need any loops, horizontally, vertically. You can keep on adding more geometry to it. Now, if you need to make a manual cut, take a knife tool, press K. You can cut a geometry in any angle or any shape you want. Just make sure it's all quad. Even though I made a cut here, it's still 1, 2, 3, 4 points here and 1, 2, 3, 4 points here. But if I make one random cut, let's say like this, then I just need to make sure that all the ends meet well. So let's click this and connect it here, and click this, connect it here with knife tool. And now we have all quads. All these are four-sided quads. Now let's say if you had a grid like this, and in this if you want to make some cut, let's say starting from here, something like this, then you can simply make a cut here. And while you're trying to make cuts, just make sure you utilize quads as much as possible. So this, I'll have to make a triangle, and we are going to convert this into quads later. So one triangle here, and then one triangle right here, another triangle here, n-gon, and triangle, n-gon, and finally one quad. And now I have kind of similar flow, but I need to make few more points here, and I need to convert these triangles and n-gons into quads. So just take a cut tool. So in scenarios like this, where you have one triangle and one 5-sided, you can simply create a cut from here to here, and then you have 4-sided quads here. Let me apply smooth so that you can see the visualization. We have quads here, and these are nicely subdividing, but here triangles are struggling quite well to manage the flow. I'm going to create one cut here, similar situation. Now we have a quad here, and one quad here. So do the same thing, create a cut, and there you go. Then let's solve this one. So mostly whatever n-gons and triangles we have fixed those. But despite of that, if I select this, it's not still quite a full loop which is connected through and through properly. To make this follow a nice and smooth arc, I'll have to make a few more adjustments here. Once we have the main line, which is this one, I'll try to form the lines surrounding it in the similar flow, like this, right here, so that it supports the flow. So now you can see kind of like a river or something, it's flowing in the similar direction. And now visualization is much more clear. What I'm thinking is I can have these loops to flow in this direction and these loops to flow something like this. Now to make this happen, I'm going to just clean up a bit. So if you find it too difficult to visualize where should I connect these triangles and how do I clean it further, what you can do is simply select few of these loops which are harder to visualize with, Control Delete to dissolve. Now you have clear path in front of you. You can make few fresh cuts right here. This is much more cleaner, and now this should also flow like this. So instead of these two at right angle, what if we connect this here or maybe right here? And now if I select this loop, you'll see it's going through and through. There are a few triangles on the outer edge, which I can solve. And now if I apply subdivision surface on this, you can see it's clearly flowing in the direction of the sketch. Now I can bevel this and extrude this, and it's going to create a smoother shape. And since all of these are in good flow and connected well, I can keep on adding more geometry to this with loops and everything, and it's going to be quite easy for me to detail this out. Then make sure the distribution is equal. Now there are few n-gons and triangles here at the borders. Alright, so now we have this flow in the direction of the initial sketch. It's following the similar flow and all the supporting surrounding edges are kind of flowing in the same direction. So to modify it into a custom flow, just make a cut first, make sure it's all quads, then connect the triangles and n-gons, shape the surrounding edges, and then you start seeing a slightly more clearer visualization of where you need to be. Then delete out few of the edges and connect and make more quads. Now let's start with few more examples. Let's say if you wanted to have a flow like this. So in that case, it's going to be quite simpler. Just make one cut here like this, and right here we have this situation. If I apply a subdivision surface, it's going to be like this. So just connect both of these and there you go. Your flow is changed right here. And then let's say if you wanted to make a flow like this, then you can simply make one cut here. Just make sure it connects with the rest of the edges and it forms the quads. There you go. The flow is now changed and it's moving like this. Now, if you're making circular formations, then for that, you don't need to make cuts. You just need to make one inset and there you go. You have this circular flowing loop, and then you can just scale out few of these. You have circular flow right here. Then you can get rid of this and then make a few more extrusions. There you go. So now this one is a circular formation. Now, as I mentioned earlier, if you have a simple plane and you apply subdivision, it becomes all round. So if you want some sharp corners, you'll just have to add few supportive loops like this. And there you have a slightly less sharper square. So the sharpness of the corner depends on how many loops you are adding. So right now there are two edges which is forming this radius. But if I add one instead and get rid of these two, then we have significantly more radius here. Now let's say if you have a situation where in the one side of the mesh you need less details, but along the way you want to add some more details, what would you do? You simply need to make a cut like this. Just remember this, and I'll also tell you a shortcut. There you go. So let's say if you needed less details here and more details here, so more loops here but not in this part, without creating any n-gons, what would you do? So let's say if we add two loops here, but in this part I don't want any loops, then I can simply move it this way and create one cut like this. Now I can get rid of these edges and there you go. We have one simple square here and I can make two rectangles here. So basically less density here, more density here. Now let's say if I wanted to have more details here, so I can use the similar kind of structure for these faces as well. You can simply create another cut like this and then you can connect it to the last one. So now instead of 3, you have 5, or you can also create one for each of these faces. Now creating a manual cut like this takes some time. So instead of this, you can simply create one inset. You can just get rid of these faces and then move it to the side. So let's say if we have one more face here, and if I wanted some more resolution here, I can create one inset, get rid of this and move it to side. And I can keep on detailing this further. So let's say if this was an arm and then I wanted more fingers, so I can subdivide like this. So there are no triangles or n-gons here. Now let's say if you had a mesh like this without interrupting the flow of the previous mesh, you wanted to reduce the number of loops here. You can simply push two of these and connect these, and then you can get rid of these edges. There you go. So you have less resolution here now, more resolution here. You can also do the same thing by ripping these apart. Select two of these, press V and rip this apart. And now you can simply fill this area and then you can dissolve these two edges. There you have quad here, and these are also quads. Or in other situations where you need to collapse the entire row of such vertices, you can simply collapse two of these. Then you can get rid of this entire thing. And now you got rid of one of the loop here, but then you have one triangle here. So to solve this, just add one right here. So this is a quad now, and these around the center one are also quad. So this kind of makes a diamond shape. It's also useful in a few of the scenarios. Now there might also be scenarios where you can't really make sense in mesh. There are just a few loops making no sense. So instead of fixing these, sometimes you can just use a simple grid fill. Just get rid of this face and then grid fill. If it says you need even number of vertices, you can just bevel one of these vertices and then you have grid fill, which works for you. And then you can fix this one. And also a really important thing, just keep in mind two triangles make one quad. So you can use this to manipulate poles. Poles are where multiple of these lines meet. These can create some weird artifacts. Just select every alternate edge and dissolve these. Then you have quad faces here. Now let's try this one more time. You can simply make one cut like this. Just remember this pattern and then you can connect it through and through, and this will subdivide it. So you have quads and you have more resolution. Or you can simply insert this, delete one side and then move it here. Now you have more resolution. Or you can simply add two loops, rip this apart, fill this area, and now you can get rid of these, and there you go. So based on the scenario, you can use any of the method. Now let's say if you had a cylindrical object like this on which you have one subdivision surface, and let's say there are two supportive loops, which makes it a tube kind of object. Now at the top you have this n-gon, which looks weird in the shading as well, and it's really important to close this properly. So to avoid this, you can simply select this guy, get rid of this face, and then grid fill. And then you can create one more inset like this. So this is how you can manage quads, manage the density of mesh, change the flow, and use the subdivision to your advantage, work with the hard angles, supportive loops, and all that. So I hope this clears out a few basics, how you can manipulate mesh flow and topology, form quads, and maintain the loop flow. Check the description for a few useful links and reference images which will help you out. Now handling retopology for large scale models with thousands of faces might seem daunting, and it is actually, but there are tools to simplify this process. Artists have developed solutions to ease the burden. For instance, the Blender add-on B-Surface allows you to draw lines of topology. This automates the generation of mesh based on these lines, enables you to create hundreds of links in the matter of seconds, and this is much more intuitive. Instead of dragging vertices, you can just sketch out few grids and you have your mesh in front of you. Additionally, for highly detailed and complex characters, sculpting or 3D scanning can be utilized to capture intricate details. Subsequently, the model can be retopologized. We discussed about this in one of the chapters from the previous series, from animated content creation series. If you're interested, just check the chapter number 6. So to achieve a good topology, understanding the strategic placement of edge loops is essential. They define the major contours and flow of your object and character, contributing to both the appearance and functionality. Use quads as much as possible. Working with quads is preferred method, and it's going to save you a lot of troubles, reducing artifacts and weird deformations when you subdivide it or animate it. Manage poles carefully, especially on curved surfaces. It matters where you position them. If you can't get rid of poles, just put it somewhere where it would create less problems. Now here are a few practices which might help. Plan ahead before you start modeling. Have a clear idea of the final shape you want to achieve. Planning helps you create an efficient and effective topology. Keep it simple. Start with something really low resolution, which is easier to manage. When the need arrives, you can keep on detailing further. Use quads, avoid n-gons, keep a printed visual reference guide in front of you if it helps. Maintain a good edge flow. Plan your edge loops to follow the natural flow of object. This is crucial for deformation and helps in creating more realistic and predictable models. Use edge loops whenever you're detailing. Instead of creating any abrupt models or cuts which will destroy the topology, try to use loops which connect end to end and close properly. This helps in maintaining a clean structure and prevents unnecessary complications for later, also possibly producing more quad-based structure. And practice with reference images. Use reference images, blueprints to guide your modeling. Keep some printed guidelines and printouts in front of you. And you can also visit few of the models on Sketchfab or maybe works by some other artist and see how they plan on their topology. Try to shuffle between subdivision mode on and off to ensure a smooth and accurate representation. What's going on behind the smooth surface, it's also really important. But remember, practice is key to improving your skills in modeling. Don't be afraid to experiment and make mistakes. So it's not going to be one day's task, or you won't be able to memorize all these at this stage. but it will become a second nature of you. In fact, by the time we are done with this tutorial, you'll have much more better command on topology. Like I mentioned, while the definitions do clear out a few things, it's beneficial to observe things firsthand, begin noticing patterns in your surroundings, and examine structures of various objects. Think about a framework of car chassis, what goes underneath the shiny surface of the car. It might help you understand the loops of the hard surfaces better. And when it comes to modeling a human face, could it be the flow of facial structure inspired it? So just think about it. As you engage in this observation, you will gradually discover various principles guiding your thoughts. So next time you model something, you won't be approaching it blank slate. To illustrate this, let's create a simplified head model for our character and observe how these loop works actually come into play. So let's jump onto this video, and we are going to create this simple head model. This might not be the most detailed head, but we are going to practice some of the topology modification in this part. So I'll see you guys in the next chapter.